Okay. Hi guys. So, so what we're gonna do in this video is rational functions, okay? Um, so this is just kind of an intro to rational functions. I don't want to do too much in this video, but I do want to kind of introduce what a rational function is, and even at the end of the video, I'm probably gonna, graph the parent rational function. So in algebra, you study rational functions. If you think about it, they are basically fractional functions. So, I know that, for example, when you would take, I know that, we've seen fractional functions before, but in linear equation form, where we would say y equals 2x plus 3, and then, you would do the inverse, and you would solve for y, and you would get x minus 3 over 2 is equal to y, right? So, I mean, this does look like a rational function, but there's a specific kind where you have to have an x at the bottom, okay? So you have to have a variable x at the bottom for it to be a rational function. Now, some examples of rational functions are y equals 2x plus 3 over x minus 1, y equals x minus 3 over x minus 1, y equals 5x minus 4 over x plus 2, etc. So, honestly, you have to have x's on top and bottom. If you don't have an x on top and bottom, you don't have to do it on top and bottom, but there does have to be a variable x on the bottom for it to be a rational function. So let me just write that down. A rational function, f of x, has to have a variable x in the denominator. Now, there are restrictions to this. So, for example, if I say 2x over x, where, and then you do this is equal to 2, right? So if I say y equals 2x over x, such that x does not equal 0, because remember that anything anything on the bottom cannot equal 0. That is a restriction. So yes, we would have a linear equation, but the main thing to notice here is that when you graph y equal to 2, you're going to have a restricted domain, okay? So yes, it will be a line, but for example, at x equals 0, y is undefined. Okay. So basically, when you do some of these functions, yes, y is undefined whenever, at x equals 0, y is undefined. So, for example, if I say f of 0, if there's a hole here, like an open circle, that means that f of 0 is undefined. Okay. So, okay, so So, yes, that is one example. Now, there are other ones that, so basically the one that I am referring to as the parent function is y equals 1 over x. So one of the things that you have to remember is how the shape of a rational function looks, okay? Like the parent rational function. I'm talking about 1 over x. Of course, there's other ones like y equals 1 over x squared, but we're not going to focus on that right now. We just want to look at y equals 1 over x. So if we go ahead and say, well, we know that 1 over 0 is undefined, so, we're not going to have anything there. If we say 1 over 1, well, of course, that would just be 1. And then as we go along, so basically if we have like a table, we go 1, 2, 3, 4, 5, 6, 7, 8, etc., right? If we graph this on the Cartesian plane here, we're going to get smaller and smaller and smaller. So we're going to have 1 over 1, which is 1, 1 over 2, which is 0.5, 1 over 3, which is, I believe, 0.25, if I'm correct. Or actually, it's... Give me a second, guys. Hold on. Give me a second. So 1 over 3 is 0.33. 1 over 4, if we do 1 over 4, that's 0.25. So notice as we go like bigger and bigger in our x values, we get smaller and smaller in our y values. Now, notice that, if we do 1 over 0, of course, that's going to be undefined. However, we're still going to have this kind of curve here. It's going to be going up and up and up and up. But it's never going to reach y equal to, or x equal to 0. It's approaching it, but it's never going to actually reach that x value because it is undefined. Now, also notice that, in algebra, they teach you about two very special type of lines to notice here, basically. So first, let me go ahead and just finish graphing this. So if I do 1 over -1, that's going to give me -1. If I do 1 over -2, that's just going to give me -0.5. 1 over -3, that's going to give me -0.33, or 1 over -3, excuse me. 1 over -4. So basically, notice that, also here, notice that -1 over 0, if we do -1 over 0, or 1 over -0, which is 1 over 0, we're not going to be like, we're still not going to have anything for x equals 0 because it's undefined. Anytime you see a 0 in the denominator, that is undefined because you cannot divide this. There's nothing, if I go ahead and divide this, there is nothing I can multiply 0 by to get 1. Now, they teach you about two very specific lines. Let me see if... Okay. So, one of the first lines is, and this is kind of vocabulary, so it's called a vertical asymptote. Okay. Now, what this is basically you are, so basically what this is the line that is a boundary. What a boundary means is that, think of it as like when people say, oh, you have to set boundaries for certain things. You know, you can't, there's a limit to what you can do. Like, you have to have boundaries, you know. That is how we look at this in math as well. A boundary is any type of line, at least I think it is any type of line that, you know, that is restricted. So basically, this cannot reach x equals 0, or y equals 0, excuse me. Well, we can also not reach x equals 0 as well, but, you know, this line here is called, or actually, hold on, this would be horizontal, my bad. So this blue dashed line that we have here is called a horizontal asymptote, and it is defined by y equals a value c, where c can be any number, basically, from negative infinity to infinity, okay? Now, there's certain rules to know about what these things, like how to find the horizontal asymptote. There are rules to know this kind of stuff, and I will go over those in a little bit, but I'm just as of right now, we want to focus on how does that look on a graph? Like, what are we looking for on the graph so that we can know, okay, what is a horizontal asymptote, what is a vertical asymptote? So, for example, so yes, this one is y equals 0. That's our horizontal asymptote. So whenever you have y equals 1 over x, y equals 0 is the, and sometimes they would how do you call it, like, they would write this as HA, meaning horizontal asymptote. So basically you would have y equals 0. As for the vertical asymptote, it is just whatever your denominator is equal to when you make it equal to 0. So, for example, y equals 1 over x, the vertical asymptote, which is, again, it's denoted as VA, that would be x equals 0, okay? So one of the things to notice here is that vertical asymptote is a line denoted by the x value. So it's a line in the, you know, basically it's a line of the form x equals c, where c goes from negative infinity to infinity, okay? What that just means is that c can be any number. It doesn't matter. And so we're going to go over a few examples. So for example, if I go ahead and let me just try to sketch a rational function very quickly. And I want you to pause the video if you can, and I want you to tell me, or just kind of figure this out and say, okay, what is the horizontal asymptote and what is the vertical asymptote? So if I have something, let me try to sketch this as best as I can. So if I have something like this, and then let me see, would be something like this, right? Sorry guys, I'm trying my best to sketch this. So it would be something like this, and then you would have, let's just say something along the lines of this, okay? It's not drawn to scale. Let me just see if I can make this a little bit better. Hold on. Okay. And I want you guys to figure out what is the horizontal asymptote, what is the vertical asymptote. So, if you could pause the video, and yeah. So, okay, so to do this, notice that we have notice that our on the left side, you know, it's from right to left, or actually, if we look at this one in specific, this one right here, the part on the right, okay? If we look at that curve in specific, to find the vertical or the horizontal asymptote, which is y is equal to c for our horizontal asymptote, okay? What you have to do is you have to see, okay, what is, you know, what y value does this curve approach to? If I move my pen this way, what is, if I keep going and going and going forever, what y value is this going to approach to? If I move my pen this way, what y value is this approaching? So mostly what they would do is, like, they would look at the two curves, right? These two curves, and they would kind of see in the middle of it, like, okay, what is the y value that is not being approached here, that is not being, like, defined here? So basically, the way that they would do it is they would say, okay, it looks like it's y equals 1. So that is the vertical or the horizontal asymptote. Now, to look at the vertical asymptote, notice that it's going down to 1, and then, you know, you have this part here, but it never, even though it kind of looks like it does, but I know it's because I'm, you know, apparently, okay, maybe like that is better, and then like this. This is not drawn to scale, guys. I'm a terrible drawer when it comes to these, but bear with me. So we have something like this. Okay, so notice that there's like a line here that is restricted, right? Notice that it looks like it's almost reaching 1, but it's not. Like, because if, for example, if I keep going and going and going, yes, it's going to get very, very, very close, but the one thing to know about horizontal asymptotes is that those dashed lines are actually never, like, you can never reach them. Like, the graph won't reach it, because it'll get very, very close, but it won't reach it. Of course, once you get to calculus, the limit would be the horizontal asymptote, but yeah, we're not going to go into that right now. But that's what you have to know here, is that the horizontal asymptote is whatever you're approaching, okay? Now, that's going to be y equals 1. Basically, this part right here. That's our horizontal asymptote. The one that is blue, that is our horizontal asymptote. Now, for the vertical asymptote, notice that, you know, as we go in terms of x and y, if you look at, like, as you go from here and then you look over here, for example, you notice that there's an x value that it looks like it's approaching, and it's getting very close to it, but it's not reaching it. And if you look at your graph, that value is x equals 1. So that, and let me actually color code this. So the vertical asymptote would be x equals 1, okay? So that's kind of the introduction of this. In the next video, we're gonna go more in depth with how to find these algebraically and, like, you know, just how to do these, how to find these algebraically versus graphically, you know. And there are special rules for finding horizontal and vertical asymptotes, especially horizontal asymptotes. Because yes, once you get to like other ones where there's a, like, for example, if I have something like x plus 1 times x minus 1 divided by x minus 1, this gets canceled out. Or like x minus 1 times x minus 5, and this gets canceled out, and yes, so we're gonna go more in depth with those in the next video. Yeah, these are very special ones, okay? So you have to watch out and be careful. So with that being said, guys, I hope this video helps. It was a very short video. It wasn't really that, I wouldn't say it was, you know, I know I rambled a lot, but it's just a very basic introduction of what horizontal and vertical asymptotes are. So I hope this helps, guys, and I will see you guys in the next video. Bye, guys.